And this water pipe cross section has an inner radius of 3 centimeters, whereas the outer radius is 6 centimeters. And within the pipe, the temperature is maintained at 100 Celsius, and the temperature is the same right throughout this 3 centimeter radius. And as soon as it touches the pipe, within that metal, temperature falls off at a rate that is determined by this function over here. And we want to find out the temperature of the outer surface of this pipe. Now, if we're giving a temperature with respect to some distance, we can find the rate of that temperature with that distance by simply differentiating it. Whereas if you want to find the temperature, we'll need to integrate. And at this stage, we want to find that temperature. So what we'll need to do is integrate this function above. And so t will be the integral of a minus 20 over x to the 0.63. All that with dx. To integrate this, we want to rearrange this so that it becomes minus 20 x to the minus 0.63 dx. Now we can integrate. Okay, just a refresher on integrating x to the n dx, because that's going to be x to the n plus 1 over n plus 1 plus c. So it becomes 20 x to the, and here we need to add 1 to this, so 0.63 plus 1, and we're going to divide it by minus 0.63 plus 1 and add the c to it. And yes, this could be tricky, so remember it's minus 20 x to the, if we add 1 we'll get 0.37, and we'll have to divide that also by 0.37, and we add the c. So now we do have a function for the temperature, but what do we do with the point plus c? So we will have a look what other information I've got over here, and I definitely have information which says that the temperature of the water is 100 Celsius all the way up to the radius of 3. So we can say that at radius of 3 we will get minus 23 to the 0.37 over 0.37 plus c. And the temperature at that distance was given to be 100 Celsius. So let's move that whole minus part of it to the other side, and we will have that c is equal to 100 plus 20 times 3 to the 0.37 over 0.37. And this is approximately 181.1639. And of course, I used a graphics calculator to determine that. So now I know that my temperature function is going to be minus 20 x to the 0.37 divided by 0.37, and then we add that constant, which is 1639. So getting back to my original question, where I want to find the temperature of the outer surface of the pipe, that means I want to find the temperature when it is 6 centimeters away. So when x is equal to 6, the temperature will be minus 20 times 6 to the 0.37 over 0.37, and I'll probably look this up on the calculator. Add this, and that's going to be, well, approximately 76.27 Celsius. Therefore, the outer temperature is going to be around 76.3. And if you're watching this, please subscribe if you haven't subscribed, and you'll get sent a lot more videos.